Hello, I'm giving this presentation trying to condense down my 40 years of experience into some helpful hints, some advice that hopefully going forward people can learn from. I started in 1979, so it gives you an idea how long I've been involved with that point in Houston. My name is Howard Stone, if you don't know me. I want to go over first a couple of pictures that kind of gives you a perspective of things that can go wrong, that can just a reminder more than anything else. And then before computers, project big ones, things that I think are important for a project. Good practice, software tools, we'll come about software tools, liability issues, precision, and then some final thoughts. So let's get started. This is a slide of an event that occurred, gosh, probably 20 years ago out near Gallup. This looks like a pretty quiescent type of flow in a river. However, it's not. And the reason is, the next slide, it's backed behind this structure that was built by a contractor, not designed by the engineer, fortunately, and it totally collapsed. And this is the second time in this area that it collapsed. You can see the C&P pipes at the bottom that have been totally overwhelmed and destroyed. The next day, it took off the entire structure. Not the kind of thing that we ever want to get involved in, and we want to make sure that if we build something, it's not susceptible to damage like this. And one more example. This is actually in North Cookie Acres area, where one storm came through, some walls collapsed, and the rock came through and took out the person's backyard and took away their swimming pool too. So it's just an example of things that can go wrong that are quite scary and things we want to try and avoid as we do our design. Okay, before computers, just a refresher. I think you all might know what this is. This is a map wheel. We used to use this a lot prior to having the benefit of GIS and having information all digital form. I think you might recognize this. This is a slide rule. We used to use this quite a bit. In fact, I came in and started engineering just after slide rules started to go away. We came in first of all with the old standard handheld computer, and we used that for a long time until real computers came in. I have at the bottom here a thing called station equation. It's a reminder of what has happened over the years. A station equation was used when you had long design projects, and like you had multiple P&Ps done by hand. It was not on the computer. And then halfway through the project, you had to do a restationing of some part of the project, or realignment. And so we had to do an equation to prevent you from redoing alignment of the entire P&P set. Something we no longer need to do because people will just redo in the computer. But back then, it was highly necessary to do it. You might recognize this as a planimeter. This is used to get the area of odd shapes, highly used in hydrology prior to GIS. Here's an example of someone, what is he doing? He's actually trying to find the centroid of an area, odd-shaped area. So he makes a cardboard cutout of the area and then bounces underneath to find the actual centroid of the area. Something, again, we no longer do, but we used to do quite a bit. Engineering experience, a couple of comments about that. It can be good. Learn from others so you don't repeat the same mistake. You want to do your best to try and learn what not to do in engineering and pass down your knowledge so people can learn from that. But it can be bad at times too. We have always done it that way as a comment I've heard in the past, and you want to make sure that if you change things, you think it through. So don't just be a slave to what we used to do. Be open to other ideas as long as you think it through and make sure it can work. And then do as I say. If you tell someone what to do that's different from what they do, you need to explain why their way was not right. I've seen it in the past sometimes where an engineer will say, just do it this way. The person didn't understand what was wrong with their way and kind of defeats their confidence level. So be careful not to use the words, do as I say. First, the project big ones. These are the ones I think that I can put together and say that you need to make sure you have these well thought out in your project right away. Right of way can be a big problem. I've seen in many projects where we get out of the right of way, we don't do the right of way correctly and don't know where it is. and the project can really go live very quickly if the right-of-way is a problem. Likewise, utilities. I think you all know, and you should know, the utilities is something we need to find where they are, because if you have a utility that crops up in the project you didn't know about, you may have to realign the project and redesign it, and that can be a major problem in the project. So do your best to make sure you have all utilities known in advance of the project. Documentation. It's always important to document what's happening in the project. Major decisions should be documented. So you have a track record looking back at what happened, because if the project's a long project and you have it go for 6 months or a year, you may forget things sometimes. And so having a documentation of that is highly advantageous. No plan-in-hand review. I've seen this happen sometimes where we say, oh, we haven't got time for plan-in-hand review. We've got to get it done real quick. And my comment to that is, if you don't take time to do a plan-in-hand review, you may miss something in the field. You can't rely upon the survey. Also, sometimes things change between the survey and when you do the construction. So to make sure you go out there and review the project with your plans in hand is very important. No geotechnical report. Sometimes we get stuck into the mode of saying, well, the project's right next door to the past one, so the soil could be just the same. So we don't need a geotechnical report. I think that's a mistake. You always want to do a geotechnical report to make sure you understand what the underlying soils are, so you can make sure you do design correctly. Repeating information in the plan set. Be very aware of repeating information such as elevations on the project. If you put them in multiple places and things change, you forget to put one in, or change one, I should say. The contractor sometimes will get the wrong one, and then you're in big trouble during the project, construction time. Engineering standard of care. Can Pierce contract shield? Engineering standard of care is something lawyers love to use because it says this is what an engineer would commonly do in a project. And if they perceive that you have not done that, then you open up to a liability issue. And I've seen it too many times where the engineer can be in trouble not doing what normally is done by an engineer. It's a very obtuse concept, but it can be very important when we get into a liability issue situation. Taking over an existing contract. In my experience, when you take over an existing contract, you always have trouble. You have such limited time to understand what the project is, and the scope sometimes says they're at 60%, so you take the last 40% and you find out that they're more than 60%. So be very aware and be very careful of getting into an existing contract, and do your best to get an expansive scope. I would encourage you to do time materials, first of all, to learn the whole project. Work outside contract scope. If you work outside contract scope, you could be liable for that if something goes awry. So always make sure you're in the scope of the contract. And if you go outside, make sure you get an amendment to the contract to decide what you're going to do and how you're going to do it. Contractor can sync a good set of plans. We don't always have control about the contract we're going to use, especially in the public sector. You want to make sure you design for a contractor who's not very good or has a good example or good head track record of finding problems on projects and causing problems. So beware of contractors who can cause problems in the project. Beware of busy, complex plan set sheets. If a project has multiple complex sheets, it can be difficult to understand in the field. And also, if you have a 6-month lag between when you design and when it goes to the field, they may ask questions. And if it's complex, it'd be hard for you to figure it out too. So make sure you don't get too complicated in a sheet. And I'll give you an example in a minute. Understanding competency, sophistication of client. Some clients are very sophisticated, and you can use terms that we commonly use in engineering, and they understand it completely. Some don't. So you need to make sure you understand your client and what their knowledge level is. And sometimes what happens is a client changes personnel, and then the level of knowledge goes down. So be very aware of your client and what they know. Copy and paste from project to project. This can happen too many times where you copy a detail from project to project. And sometimes it doesn't actually work in the second situation, or can be a problematic detail that should not have been copied in the first place. So be very careful when you copy from project to project. I know it's easy to do, but it can cause problems. Here's an example of a very complex plan sheet. This takes a while to figure out what's going on here and how to do things. And I think the problem is here, we try to get too much in one plan sheet. And the problem, it definitely comes into obvious problems when you have the contractor ask you a question about something in the plan sheet, and it may be 6 months since you did it. So I'd be very wary of doing sheets as complicated as this and try best not to. Good practice. I've often found that management by walking around is a highly advantageous tool for project managers. And what I mean by that is not just going around and saying, hi, how is it going? You want to stop and see what they're doing, what problems they're having, and have them show you where they're at. That way you get a good feel of the project. It doesn't take a lot of time. It can be very advantageous trying to head off problems before they become big problems. How are you going to build that? Sometimes I can ask an engineer and I say, well, that looks like something that's hard to build. How are you going to build that? And the engineer will look at me and say, well, the contractor will figure it out. No, you've got to have an idea how to build it yourself, first of all. He may have a better idea how to build it, but you understand how to build it. For example, putting a simple concrete crossing structure that's too close to the right-of-way and you can't get down there without doing some type of major shoring could be a real problem. So you need to make sure you understand how it could be built. Have you read the contract scope? The scope should be read by everybody in the project because you need to understand what it is and what the limitations are. And so you can help the project manager by being aware of it too. So definitely be aware of the contract scope and what you have to do. You know the project deadlines. The other side of the coin when project scope is the deadlines. What do they do? What you don't want to get into is finding out that your project deadline's a week away and you've got 4 weeks of work to get it done. So being aware of project deadlines and keeping the client apprised of where you're at, and it'd be better to give them a month advance notice about a project deadline that's a problem as opposed to a day before. Know the strengths and weaknesses of the team members. Some team members are really good about coming to ask you questions. They're not understanding this here and want to get some explanation. Others aren't as good as that. They try and figure out themselves and waste too much time. So you need to know who your members are, what their strengths are, what the weaknesses are, so you can take advantage of that in the project. Software tools, intelligent design. We all recognize that the tools are getting more sophisticated, and we want to make sure that we understand what the project is doing with those tools and how you apply those tools. And so sometimes we get in the trap of having the software almost kind of start from scratch and just do trial and error, where you can actually spend some time up front and figure out how to attack the project and not spend as much time doing trial and error. Understanding the tools between the manager, the doer, and the reviewer. The manager needs to understand what the tools are and how they work, not to the point of pushing all the buttons, but understanding the concepts behind it and being able to move around in the software itself so you can look at it while it's being designed, as opposed to looking at the P&P sheet coming out. I think it's much more advantageous to get an idea of what's going on in the project that way. Likewise, the doer needs to have a good understanding of the project tools and what tools should be used with their design. And the reviewer is also better off understanding the tools and being able to look in the tools a little bit sometimes to help in the review process. It can vary for what type of project we're talking about, but those three people and how they interplay, the manager, the doer, and the reviewer, are very important in how we apply the project tools and how we end up doing the design. And then applying the right software tools. Sometimes we get to the point of doing a very complex tool for a simple project or simple detail. So make sure you apply the right tool so you don't spend too much time setting up a software tool, understanding later that it was too complex. Mistakes resulting in liability. I will have some repeats here, but I think it's important. These are all things that occurred in other previous projects that caused liability issues. So I want to highlight them as we go through. Messy or busy plan sheets, like the one I showed you before, that did result in a liability issue. So be very aware of how complex the plan sheets are. No stationing. A surveyor created their own. In this project here, the surveyor working for the contractor made up their own stationing. We didn't do one. And it caused problems with the project about when things got laid out. Surveying, mapping, vertical bust. That has happened a couple times in the past where we had a survey bust or mapping bust. No one understood it. And it became a problem in the project and caused a liability issue. So no way to prevent against this. But if you see something that doesn't look right, make sure you go back to surveyors and ask the question to make sure you can get a good understanding of what's going on. Providing elevations more than once. This has happened at least twice that I can recall where we had more than one elevation of the same piece of information on the plan set. We changed one, didn't change the other, and the contractor got the wrong one and put it in. And then we had to redesign a portion of the project. Provide surface to contractor. We're getting more and more contractors now that use highly sophisticated tools, and they put their surface into a machine and they go ahead and do grading. That behooves us to make sure that our grading plan matches the plan sheet. And so that's a very important thing to do. I've seen where before we didn't have the surface completely figured out all the way, and it got us in trouble in terms of trying to make the project work. Insufficient detail. Contractor went wild. Kind of interesting way to say it. But if we don't provide enough detail on the project, the contractor assumes what he wants to do and goes for it. Now, a good contractor will actually come back and ask you, I don't understand how to build this. Please give me more detail. Others just go ahead and build what they think what's going to be. And then later on, we discover that it doesn't work. Earthwork. We all recognize earthwork is difficult to understand, to define for us and the contractor. In most cases, we recognize that, and we do a pretty good job. There was one project, though, we had different types of earthwork, and that caused a problem because they had different prices for those different earthworks, and then they didn't work right. And the contractor was able to get a change order to get it done, but we had to pay part of it, which was not a pleasant situation. Key decision. I skipped over project decision, no documentation from client. This has happened too many times where the client did not give us a written information to say, go do this. So he gave us a decision or direction orally. Or in one case where I was involved, the engineer actually put on the report what he was going to do. And later on became a big liability issue, and it was determined that, well, he put it on there, yes, but the client never told you to do it. And it became a big issue, and the client was able to get out of the problem, not paying any money where the contractor had, where the engineer had to. Same thing with where the sub to a prime. Make sure that any key decision is given to you in writing from the prime. Again, we had a project where that did not happen. And so we're involved in the liability issue and had to pay more money because of that, because we didn't have any direction from the client, from the subject consultant that we could point to and say, this is what he told us to do. Bust in quantity estimate. Shouldn't be here. Why is it? My position on this is, if we have a bust in quantities, it's something the project should pay for. The client should pay for any change in quantities because it's part of the project. However, sometimes when we have a client we have a good relationship with, we want to keep them as a client. Sometimes we may pay a portion of a quantity bust to keep them happy and to keep as a client, keep them as a client going forward. The general rule, though, I'll give you a good example. One of our projects that the lawyer conveyed to me was, well, they wanted us to pay for additional light pole. And the lawyer says to the client, well, if we're going to pay for it, we're going to take it. It's our light pole. And it's a good example of showing it's part of the project. So they need to pay for it. Exploding toilet. I put this in here. It actually happened on a project. Example of something you can always anticipate happens. It's a pressure toilet, and it wasn't funny because the worker went out there to exercise the toilet for the first time and exploded in his face, and so he actually had shrapnel in his face. So it was a very bad situation. You can't anticipate. I put in just a reminder that we can't always anticipate everything, but when we do, make sure you pay proper attention to what happened and get involved early, trying as best to decide what to do with your lawyer. If a death involved, all bets are off. I only had one project where a death occurred, and in that case, the lawyers were more of the ambulance chasing type, and they were after everybody who came even close to the project. So if you have a death involved, you want to make sure you do your upfront work right away, understand what's going on, and make sure that the lawyer representing you is going to be involved from the very beginning. So you can do your best to try and protect yourself, but it's very difficult. Payment items. Again, I have earthwork here. A reminder of how do you pay for it, how do you measure it. I know there are sometimes projects where we measure by truckload. That's the worst way to do it because the earth is fluffed up in the condition that you really can't measure it very well. So in that situation, you probably do a lump sum and not even do a measure it in payment. So make sure that you do your best effort on earthwork to protect yourself from a big change in quantity, or because the contractor tries to get away with something. You want to make sure you hold his feet to the fire about how you measure it and how you pay it. Specification items do not match bid items. This has happened a couple of times where we specify something in the specs, doesn't match the bid item. So that can cause a problem with description, payment, etc. Structural wall failure. Again, something we don't want to get involved in. It's happened where a wall failed and we had to pay money for it. So make sure that if you do a structural wall or any other structure you do, that it's going to stand. And I know it can be hard to do that all times, but it's happened in the past. Granite structure failure, likewise. You saw that example before about a granite structure that failed. In that case there, we weren't involved, but we did have a couple of these that have occurred. So you want to make sure that your structure can protect yourself against a rather large event. New products from suppliers. I added this because I know of at least two projects where we designed a project with a new product from the supplier that sounded really good, could save the client a lot of money, but sometimes they don't work out well, especially in our dry environment. So make sure that if you want to try a new product, you do your homework to make sure that's going to work. But the supplier will not stand behind you if a liability happens. Precision. A few comments about precision. We sometimes get enamored with what the computer does. And here's some real world examples of projects where we had a curve number for 85.4232. We'd be lucky if we had the whole number correct, not to mention anything else. Same with flow rate, 24.32. Velocity, elevation. They're just examples of things that make us look a little silly when we put them on the plans, and the contractor will say, well, yeah, sure. I'm going to put an elevation down there to 0.342. Understand what you're dealing with. And I put in there accuracy. Never forget that accuracy and precision are totally different. It can be very precise, but very inaccurate. So keep those two in mind. I've had projects where we sometimes had to go to the whole foot. We couldn't go any more precise than that. So keep that in mind as you do your project. Some final thoughts. Design assuming you will have a bad contractor. Too many times we've had a contractor who isn't that good, sometimes not even qualified what they're doing, but they have the right license. So you want to make sure that your plans protect yourself as best you can from a contractor who's not very good or is looking for ways to get more money out of the project. We should not pay for quantity errors. Again, a reminder, a quantity change in the project is part of the project. The only time we actually have a problem with that, in my opinion, is when the quantity changes to the point that the contractor says, I need a change in quantity cost. for the item. And so we may have to get into a discussion about if it costs $40 per cubic yard and that costs 45 because the additional, we may have to get in discussion about that. Never been sued for analysis product reports. So far, in New Mexico, reports have never resulted in a liability issue. And just a reminder that hopefully it'll never happen, but to be aware that so far that's a true statement. Always have a separate review. Make sure that someone outside your project is reviewing your project for a different second set of eyes, because you may get too tunnel vision into what you're doing and not see something that an outside person may see. So always make sure you have a separate review. And I think that's true for both analysis and design. Finally, good luck. It's a very litigious world out there, and I've had too many examples of litigious projects that have gone sour. They're not fun to deal with. They take a lot of effort, and we've always tried our best to support them when it happens. But if we could do those steps up front that I talked about for a project, big ones, you limit what your exposure is and perhaps do a project that doesn't have a litigious part of it. So thank you and good luck.